Scope of work for ESD fire and gas system. The emergency shutdown, ESD, and fire and gas F&G system encompasses the design, manufacture, supply, installation, testing, and commissioning of a comprehensive safety and emergency response system. This system is essential for ensuring the safety of personnel, equipment, and the environment in an offshore production platform environment. The scope of work broadly includes 1. System design and engineering. Development of a detailed functional design specification, FDS. Integration with existing control systems, including DCS and various unit control systems. Configuration of graphical interfaces for monitoring and control. Site surveys to assess existing system architecture and capacity. 2. Manufacturing and supply. Provision of fully engineered and assembled system cabinets, marshalling cabinets, and related hardware. Supply of dual redundant processors, I/O modules, power supplies, and communication equipment. Hardware and software necessary for system operation and integration. 3. Installation and integration. Installation of ESD F&G equipment in specified local equipment rooms. Integration with existing control systems and ensuring compatibility. Implementation of required upgrades to firmware or software for seamless integration. 4. Testing and commissioning. Comprehensive factory acceptance testing, FAT, and site acceptance testing, SAT, to ensure system functionality and compliance. Pre-commissioning and commissioning assistance, including loop checking and troubleshooting. Support during the startup phase to ensure smooth operation. 5. Documentation and training. Provision of detailed system documentation, including installation guides, wiring diagrams, and user manuals. Training programs for operators and maintenance personnel to ensure proper system operation and upkeep. 6. Project management. Ongoing project management and coordination with various stakeholders. Regular project progress reporting and communication. Responsibility for meeting project deadlines and ensuring deliverables are completed to the required standards. The ESD F&G system aims to provide a high level of safety and operational integrity with features such as redundancy, fault tolerance, and real-time monitoring and control. The system is designed to meet industry standards and regulatory requirements, ensuring reliable and efficient protection for offshore production facilities. Vendor responsibility. Vendor responsibility consists of the following as a minimum. 1. Coordination, project report generation, and execution of the ESD F&G system. 2. Responsibility for the design, manufacturing, and approval of the equipment and any integral part thereof rests with the vendor, and neither anything contained in this specification, nor possible purchaser approval of plans, drawings, calculations, etc., shall relieve the vendor from said responsibility. 3. Any other information required by the vendor to complete integration with the existing control system will have to be obtained during site surveys and interface with existing systems. 4. Any conflict between the requirements of this specification and related codes, standards, datasheets, drawings, requisitions, etc., shall be referred to the purchaser for clarification. 5. Full responsibility for ensuring the equipment is designed, manufactured, approved, and tested according to the specification and normal practices for such equipment. 6. Ensuring the total system, including sub-suppliers' systems, is covered by a warranty for a specified period. 7. Ensuring materials and work meet the satisfaction of the purchaser and company. 8. Preparation of any additional documents or drawings required for system integration, even if not specifically listed in the specification. 9. Identification of necessary serial link interfaces with existing systems and other packages. 10. Supporting all system hardware and firmware with spare parts and service for the platform's designed life, and providing upgrades and revisions of the software for a specified period. 11. Ensuring all software licenses are registered to the company. 12. Ensuring the ESD F&G system provides the highest possible level of operational security with redundancy for critical components. 13. Project management for system activities during the entire project duration, including assigning a qualified project manager and project engineer. 14. Full responsibility for designing and delivering the sub-supplier's scope of supply and work to make the system fully compliant with the specification. 15. indicating clearly in the table of compliance either deviation from or acceptance of each item of the specification. No deviation is allowed unless approved by the purchaser. 16. Ensuring compliance with the specification does not relieve the vendor from responsibility for completeness, satisfactory operation, and ease of maintenance. 17. Ensuring all interface components used in the SIL3 ESD F&G system comply with availability figures as guided by relevant standards. 18. Entering into separate service agreements covering planned maintenance, spares provision, and specialist services for a specified period. Design information. Given by purchaser. The following documents will be given to the vendor to implement the system: process flow diagrams, PFDs, piping and instrument diagrams, PNIDs, ESD and FGS cause and effect matrix, control system block diagram, SEAL study report, ESD and F&G IO list, local equipment room, LER, layout, fire and gas layout, DCS function block diagram, existing functional design specification. System functional requirements. The ESD F&G system shall incorporate emergency shutdown systems and fire and gas systems within a fully integrated, independent, standalone unit which interfaces with the DCS for status and alarm monitoring. The ESD F&G system will have individual processors for ESD and F&G operations with separate I/O, hardware, and software so that a failure of an ESD or F&G element does not affect the other. Emergency shutdown system ESD1. Monitoring and control. The ESD system shall monitor all areas for process conditions outside the normal range of control. It shall automatically protect personnel, equipment, and the environment by initiating appropriate alarms and shutting down the plant either partially or fully as per cause and effect sheets. 2. Replacement and repair. It shall be possible to replace and repair any faulty system module without degrading the operation of the system. Module replacement shall not require system shutdown or disruption of the scanning process, or freezing of output states. 3. Synchronization. ESD system shall have a facility for automatic synchronization to the DCS master clock with an accuracy of 10 milliseconds. The synchronization mechanism must be clearly detailed by the vendor. 4. Processor capabilities. The main processors shall have the capability to implement all control functions required to execute the logic schemes. Redundant processors shall execute the same instructions, programs, and cross-check the outputs continuously. Fire and gas system, F&G. 1. Monitoring and action. The F&G system shall ensure the safety of personnel and equipment and the protection of the environment in the event of fire or gas detection. It shall monitor a range of detection and protection devices distributed throughout the plant. Upon detection of a hazard, the system shall take appropriate action to initiate alarms, release extinguishant, shut down equipment, and potentially close down the facility. 2. Notification and interface. All alarms and actions initiated by the ESD F&G shall be notified to the DCS and the main control room. The system shall interface with the DCS through dual redundant serial links for status and alarm monitoring. 3. System independence. The F&G system must operate independently of the ESD system to ensure that a failure in one does not affect the other. Separate I/O, hardware, and software must be provided for ESD and F&G functions. General requirements. 1. Online logic reload. The system shall allow for online reloading of logic changes without causing a shutdown, with detailed procedures and precautions provided by the vendor. 2. System synchronization. The system must synchronize with the DCS master clock, ensuring time accuracy within 10 milliseconds. 3. Safety integrity level, SIL. The system design shall meet safety integrity level, SIL 3 requirements and be TÜV certified. 4. Specific functional requirements. Early detection of hazardous conditions and initiation of appropriate alarms. Implementation of plant shutdowns and blowdowns as required. Isolation of hazard sources and ignition sources. Activation of extinguishant systems and visual and audible alarms throughout the facility. Continuous monitoring and reporting of system status to operators. System size and capacity. 1. I/O processor modules. Provide I/O processor modules with an additional 20% margin for fully wired installed spares. Ensure system mass memory can hold all system and application software and database with the capacity for future programming and configuration. Supply 24-volt DC power to all field devices from dedicated power supplies with proper sizing for maximum load capacity. Ensure all intrinsic safe I/O channels are equipped with galvanic isolators. Detailed specifications. 1. ESD functional requirements. Early detection of potentially hazardous conditions. Initiate visual and audible alarms on the platform and in the main control room. Implement plant shutdowns and blowdowns. Provide information to operators regarding plant and system status. 2. F&G functional requirements. Early detection of hazardous atmospheres. Initiate visual and audible alarms on the platform and in the main control room. Isolate the source of the hazard and all sources of ignition. Initiate extinguishment systems where applicable. Implement plant shutdowns and blowdowns where necessary. Provide visual alarms, beacons, in high-noise areas. 3. System components. Processors, dual redundant, capable of executing control functions and cross-checking outputs. I/O modules, galvanically isolated, supporting both analog and discrete signals with diagnostic indicators. Power supplies, redundant 24-volt DC, capable of supporting all connected devices in future expansions. Memory, non-volatile, capable of storing system and application software with sufficient capacity for future configuration. Communication, dual redundant serial links for interfacing with DCS and other systems. 4. Safety and reliability. The system must be designed to be fail-safe, with normally energized circuits. High availability with an excess of 99.92%, including all equipment from input to output. Full MTBF and MTTR calculations to be provided. By adhering to these technical specifications, the ESD F&G system will provide reliable, high-integrity protection for personnel, equipment, and the environment, ensuring safe operation and quick response to emergencies. Hardware requirements, ESD F&G hardware. General requirements. 1. Card replacement. It shall be possible to replace cards without switching off the power or disturbing the process. Short-circuiting of individual inputs and outputs shall not affect other inputs and outputs. Theoretical failure rate figures according to HDBK 2117 of all boards, power supply units, and other functional subassemblies in the system shall be stated. Calculations shall be based on the worst case and the normal environmental conditions. 3. Anti-static precautions. The vendor shall state if anti-static precautions are necessary when handling the cards. If required, grounding wrist straps shall be supplied. 4. RFI immunity. The entire system shall be RFI immune. System cabinet. 1. Cabinet specifications. Maximum cabinet size, 800 mm W by 800 mm D by 2100 mm H. Standalone cubicles housing a fully integrated emergency shutdown and fire and gas detection system. Dual redundant TUV certified programmable logic controller (PLC) system suitable for SIL3 applications. Separate hardware for ESD and F&G, including dual serial data communications equipment and dual power supplies. Front-only access with swing frame arrangements and bottom cable entry. Cabinets shall be tagged as per project tagging philosophy. System matrix TFT LCD. 1. Display requirements. A soft touchscreen matrix TFT type display shall be mounted on the front face of the ESD F&G system cabinet. Vendor to propose a suitable VDU-based system visible from outside to operate overrides, trip actions, etc. Password protection to avoid unauthorized operations. Geographic layout of the platform with fire and gas zones, major equipment, field sensors, alarm status, deluge release, trip actions, system diagnostics, and alarm controls. Tile matrix display. 1. Display panel. Integrated ESD F&G common facilities matrix on the front panel. Hardwired tile matrix type with audible alarms, alarm accept reset, master key switches for overrides, local control via TFT interface, and hardwired shutdown push buttons. ESD F&G printer. 1. Printer integration. Separate printer not required. Events integrated into the DCS and printed using the DCS system printer. Port available for an external printer if required. Operator station. 1. Station requirements. No separate operator station required for ESD F&G system. All graphics related to ESD F&G displayed on the DCS operator station. Marshalling cabinets. 1. Cabinet segregation. Separate cabinets for AI, AO, IS, and DIS, DI, NIS, and DOR. Accommodation for wiring terminations, IS. Circuits, external interface systems, serial I/O terminations, system cable terminations, power supplies, and other necessary components. 2. Mechanical construction, Riddle TS series cabinets with paint finish RAL 7DAO32. Heat extraction fans and dust filters designed to be bolted together with detachable, lockable doors. Bottom-mounted removable gland plates for cable entry with IP42 ingress protection. Ventilation. 1. Heat management, full heat rise calculations for each cabinet. Forced ventilation systems with filtered intake louvers, twin parallel systems rated at 100% duty. Fan failure and high internal temperature alarms included in the cabinet common utility alarm. Equipment identification. 1. Labeling, stainless steel equipment labels with black lettering, permanently screwed to the front face. Internal equipment identified to manufacturer's standard, no dymo, tape, or similar. Wiring requirements. 1. Cable specifications. Flame retardant insulated multi-stranded copper conductors, 600 1000 volt grade, non-halogenated smoke type tested to IEC 332-1. Plastic trunking for wiring, with segregation for intrinsically safe and non-intrinsically safe circuits. Preformed system cables for wiring connections between system and marshalling cabinets. Clear identification and tagging of terminals with loop tag numbers. 2. Wiring colors, 24-volt DC positive, red, 24-volt DC common, black. S-circuit, blue non-intrinsic safe, gray. Instrument signal earth, green, 230 volts AC phase, brown. 230 volts AC neutral, blue, 30 volts A control circuit, brown, black. ES earth, green, with blue sleeves on ends. Safety earth, green, yellow. 3. Grounding, ground wiring designed per vendor standard and in conformance with 2V Class 6 safety equipment certification requirements. I/O requirements. 1. General specifications. Each I/O module galvanically isolated from external circuits, capable of handling short circuits without affecting other I/Os. Maximum 16 points per module, protected against power supply polarity reversal. 2. Analog inputs. Capable of processing specified analog signals with 750 ohms load capability. Software configurable range supporting 0 to 20 milliamps range for fire and gas detector fault monitoring. Capable of processing signals from smart transmitters, supporting both 4-wire and 2-wire configurations. Open, short circuit, and out-of-range detection with results available for logic sequences. 3. Discrete inputs. Sensing voltage of 24 volts DC at 0.1 amps, incorporating contact bounce suppression. Capability to handle various types of switches and push buttons. Line monitored design for non-fail-safe inputs, galvanic isolators for intrinsic safe signals. 4. Discrete outputs. Powered outputs to XD solenoid valves, matrix panel LEDs, beacons, and relay coils. Individual external voltage sources for each output point with surge protection, arc suppression, and fuse disconnects. By adhering to these detailed technical specifications, the ESD F&G system will provide reliable, high-integrity protection for personnel, equipment, and the environment, ensuring safe operation and quick response to emergencies. Genware requirements. 1. Configuration and flexibility. The ESD F&G system software must be configurable to meet all specified functional requirements. The software must allow for online modification without requiring system shutdown or interrupting ongoing processes. 2. Standard software packages. The following standard software packages must be provided: system configuration and management software, diagnostic and troubleshooting software. Interface software for communication with DCS and other external systems. Data logging and reporting software. Software for handling ESD and F&G logic, including cause and effect matrices. 3. Graphical user interface. The software must include a user-friendly graphical interface for system monitoring and control. The GUI should display real-time data, system status, alarms, and events. Graphical representations of the plant layout with clear indication of sensor locations and statuses must be included. 4. Diagnostics and maintenance. The software must include comprehensive diagnostic tools to identify and troubleshoot system issues. Maintenance procedures and schedules must be integrated into the software for routine checks and preventive maintenance. Alerts for maintenance actions and potential system faults must be provided. Emergency Shutdown System, ESD software. 1. Functionality. The ESD software must handle all emergency shutdown logic, ensuring safe shutdown of plant operations in case of emergencies. The software should include predefined logic sequences for initiating shutdowns based on process conditions. Cause and effect matrices must be programmable to define the specific actions to be taken under various conditions. 2. Alarm management. The software must manage alarms for process deviations and equipment malfunctions. Alarm prioritization based on severity and impact with distinct audible and visual indicators. Historical logging of alarm events for post-event analysis. Fire and gas system software. 1. Detection and response. The F&G software must monitor fire and gas detectors and initiate appropriate responses. Automated actions include triggering alarms, activating suppression systems, and isolating hazard areas. Interface with fire and gas sensors, ensuring real-time data acquisition and processing. 2. Graphical displays. Real-time display of fire and gas zones, detector statuses, and active alarms. User-configurable graphics to reflect the plant layout and sensor placement. Visual indication of safe and hazardous areas with color-coded alarm zones. System integration. 1. Communication protocols. The software must support standard communication protocols for interfacing with DCS and other external systems. Dual redundant communication links to ensure reliability and fault tolerance. Capability to exchange data with DCS for system status, alarms, and control commands. 2. Data logging and reporting. Continuous logging of system data, including process variables, alarms, and events. Automated generation of reports for system performance, maintenance activities, and incidents. User-accessible logs for detailed analysis and regulatory compliance. Security and access control. 1. User access levels. The software must support multiple levels of user access with password protection and user authentication. Different access levels for operators, supervisors, and engineers, with role-based permissions. System security. Protection against unauthorized access and cyber threats. Regular software updates and patches to address security vulnerabilities. Secure communication channels for data exchange and remote access. Compliance and certification. 1. Safety integrity level, CL. The software must comply with SIL 3 requirements and be certified by TV or an equivalent authority. Documentation of safety and reliability features, including failure mode analysis and redundancy mechanisms. 2. Regulatory standards. Compliance with industry standards and regulations for safety systems, including IEC 61508 and IEC 61511. Documentation and certification of adherence to relevant standards and practices. By adhering to these detailed software requirements, the ESD F&G system will provide robust, reliable, and user-friendly functionality, ensuring effective monitoring, control, and response to emergencies, thereby safeguarding personnel, equipment, and the environment. Power supplies general requirements. 1. Redundancy. The ESD F&G system must include redundant power supplies to ensure continuous operation in case of a single power supply failure. Each power supply must be capable of supporting the full load of the ESD F&G system independently. 2. Capacity. The power supplies must be sized to handle the maximum load, considering all connected devices and future expansions. Power supplies should provide stable and reliable power to all system components. UPS system. 1. Uninterruptible power supply, UPS. An uninterruptible power supply, UPS, system must be provided to ensure continuous power supply to the ESD F&G system during power interruptions. The UPS system must have a battery backup capable of maintaining power for a specified duration under full load conditions. The UPS must include automatic switchover features to engage battery power without any interruption to the ESD F&G system operation. 2. Battery backup. The UPS battery backup must be capable of supporting the ESD F&G system for a minimum of 30 minutes at full load. Battery health and charge status must be continuously monitored, with alarms for low battery and battery failure conditions. Power distribution. 1. Distribution panels. The power distribution system must be designed to avoid single points of failure, ensuring continuous operation of the ESD F&G system. Protective devices such as circuit breakers and surge protection devices must be included to safeguard the ESD FNG components. 2. Segregation. Power distribution panels must segregate power supplies for ESD, FNG, and other critical systems to prevent cascading failures. Proper labeling and documentation of all power circuits must be provided. Power supply monitoring. 1. Status monitoring. The ESD FNG system must include monitoring features to continuously check the status and health of the power supplies. Alarms must be generated for any power supply faults, including voltage irregularities, overload conditions, and UPS battery status. 2. Integration with ESD FNG system. Power supply status must be integrated into the ESD FNG operator interface for real-time monitoring and diagnostics. Detailed event logs for power supply failures and recoveries must be maintained for analysis. Cabling and wiring. 1. Cable specifications. All power supply cables and wiring must meet industry standards for safety and performance. Cables must be flame retardant, low smoke, and halogen-free, with proper insulation ratings. Power cables must be routed separately from signal cables to prevent electrical interference. 2. Grounding. Proper grounding and bonding must be ensured for all power supply components to prevent electrical hazards. Separate grounding systems for safety earth and instrument earth must be implemented. Redundancy and reliability. 1. High availability. The power supply system must be designed with redundancy to ensure high reliability and availability of the ESD FNG system. Redundant power supplies must automatically take over in case of a primary power supply failure without any manual intervention. 2. Maintenance and testing. Regular maintenance and testing procedures must be established to ensure the power supply system remains in optimal condition. Scheduled battery replacements and UPS system checks must be part of the maintenance plan. 1. Operating conditions. Power supply components must be designed to operate within specified environmental conditions, including temperature and humidity ranges. Cooling and ventilation systems must be provided to prevent overheating of power supply units. 2. Protection. The power supply system must be protected against environmental factors such as dust, moisture, and corrosive elements. Enclosures for power supplies must have appropriate ingress protection ratings. Design and performance criteria integrity. 1. High availability. The ESD FNG system is an essential part of the platform and must embody a high availability figure and a high level of integrity. The design of the ESD FNG system must meet CL3 requirements and be TÜV certified. Achieve high integrity by using high reliability components, implementing hardware redundancy where appropriate, employing comprehensive self-diagnostic/testing systems, ensuring ease of module replacement. 2. System robustness. The system must be highly resistant to hardware and software malfunctions. Any single fault within the system should not result in a total shutdown. The ESD system should be designed to be fail-safe, normally energized except for LED lamp output/breaker as appropriate. A 1 logic is the normal state, and a 0 logic signal indicates an abnormal, trip failure state. All I/O modules should be capable of being changed out online without damage or disrupting plant operation. Availability. 1. System uptime. The availability of the ESD FNG system must exceed 99.92%, including all equipment from input to output components. Full MTBF, mean time between failures, and MTTR, mean time to repair calculations must be provided as part of the VDRL document submission. Performance. 1. Response times. The ESD FNG system must maintain the following performance criteria regardless of system loading. Initiation of input to activation, less than 0.5 seconds. Time synchronization accuracy, less than 10 milliseconds. Sequence of event, SOE, based on the CPU cycle time of the system. Scan rate through serial link, 1.0 second. Time stamping, less than 10 milliseconds. 2. System expansion. The system should be designed to allow for future expansion without significant reconfiguration or performance degradation. By adhering to these design and performance criteria, the ESD FNG system will provide robust, reliable, and high-integrity protection for personnel, equipment, and the environment, ensuring safe operation and quick response to emergencies. Testing. General testing requirements. 1. Factory acceptance testing, FAT. FAT must be conducted to ensure that the ESD FNG system meets all specified requirements before delivery. The FAT procedure should include functional testing, performance testing, and integration testing. Vendor shall supply appropriate hardware and software to simulate PLCs within equipment provided by others, confirming correct data transfer and protocol compatibility of the serial link interfaces. The software within the DCS controllers, ESD FNG CPUs, and operator stations shall be fully tested for compliance with the functional requirements defined within the specification and other purchaser's documents furnished in this RFQ. RF interference test. This test shall be conducted by operating a portable radio of frequency and power defined by the purchaser at a distance of 1 meter from each item of the equipment with doors fully open. The system shall be monitored for abnormal indications or spurious data. 2. Site acceptance testing. The ESD FNG vendor shall be involved in the site acceptance testing of the entire system. All equipment resources required for S8 shall be provided by the vendor. Full details of the SAT procedures shall be provided by the vendor. The system shall be fully integrated with the existing PS1 system, including the brownfield scope as outlined in Appendix D. Testing scope and procedures. 1. Loop check and functional logic check. Power up the system and conduct a SAT for the system. Loop checks and functional logic checks should be performed to ensure all connections and system logic are functioning correctly. Vendor to assist the fabrication contractor during these checks. 2. Site acceptance test. Vendor to conduct SAT as per the vendor-developed procedure approved by the purchaser. SA to confirm the functionality and performance of the ESD FNG system in the operational environment. 3. Offshore startup assistance. Vendor to assist with the startup of the ESD FNG system offshore, ensuring the system is fully operational. Post-startup support until first gas out, including system maintenance and support services. Provision of maintenance for system software and hardware, modifications control, implementation, and documentation. Maintenance and support. 1. System maintenance and support services. Vendor shall provide maintenance and support services for the life of the control system. The details of these services to be discussed and agreed upon with the purchaser. By following these detailed testing requirements, the ESD FNG system will be thoroughly validated to ensure reliable and efficient operation, safeguarding personnel, equipment, and the environment. Documentation. General documentation requirements. 1. Detailed design documentation. Detailed design documentation must be provided, including system architecture, hardware specifications, software configuration, wiring diagrams, and system schematics. Documentation must include I/O schedules, control system block diagrams, and a comprehensive list of all system components. 2. Installation and configuration documentation. Step-by-step installation guides must be provided to ensure proper setup of the system hardware and software. Configuration manuals detailing the setup and customization of the ESD FNG system must be included. 3. Operation and maintenance manuals. Comprehensive operation and maintenance manuals must be provided, covering all aspects of system operation, routine maintenance, troubleshooting procedures, and emergency handling. Manuals must include information on system calibration, testing procedures, and spare parts lists. Documentation required prior to FAT. 1. Test procedures. Detailed procedures, programs, and test sheets for system testing at the factory, on-site commissioning, and routine operation and maintenance. Include procedures for all associated equipment and bought-in items from sub-vendors. 2. Safety certification dossier. A complete dossier of safety certifications for the ESD FNG system and all associated equipment. Certificates must comply with relevant safety and regulatory standards. 3. Operation and maintenance manuals. Manuals containing all necessary information for the continued operation and maintenance of the system during its life cycle. Documentation required on delivery. 1. As-tested documentation. All drawings and documentation must be updated to reflect the as-tested status, incorporating any modifications and corrections identified during FAT. Final documentation package. A complete set of updated documents, including system schematics, configuration details, test reports, and certificates. Documentation must be organized and indexed for easy reference and retrieval. By adhering to these documentation requirements, the ESD F&G system will be thoroughly supported with clear and comprehensive information, facilitating proper installation, operation, maintenance, and management. Project Execution Plan. Project Management. 1. Project Manager. A dedicated project manager must be assigned to oversee all activities and serve as the primary contact for all official communications. The project manager is responsible for coordinating with all stakeholders, including the client, subcontractors, and internal teams. 2. Project Schedule. A detailed project schedule must be established at the kickoff meeting, outlining all target dates for document transmission, equipment delivery, installation, testing, and commissioning. The schedule must be reviewed and updated regularly, with any changes communicated to all relevant parties. 3. Progress reporting. Bi-monthly written job progress reports must be issued to the client, detailing the current status of the project. The reports must include updates on design, procurement, manufacturing, installation, testing, and commissioning activities. Documentation and reporting. 1. Design documentation. Detailed design documents must be prepared and submitted according to the agreed schedule. This includes system architecture, hardware specifications, software configuration, wiring diagrams, and system schematics. 2. Installation and configuration documentation. Step-by-step installation guides must be provided to ensure proper setup of the system hardware and software. Configuration manuals detailing the setup and customization of the ESD F&G system must be included. 3. Testing and validation documentation. Test plans and procedures for factory acceptance testing, FAT, and site acceptance testing must be provided. Test reports documenting the results of all testing activities, including performance tests, integration tests, and validation tests, must be included. Design and engineering. 1. Site surveys. Site surveys must be conducted to gather necessary information for system integration. The surveys should assess the existing system architecture, capacity, and any specific requirements for integration. Detailed engineering. Detailed engineering must cover all aspects of the system, including hardware, software, and interface requirements. The design must meet all specified functional and performance requirements. Procurement and manufacturing. 1. Equipment procurement. All equipment and components must be procured according to the approved design specifications. Quality control measures must be in place to ensure all items meet the required standards. 2. Manufacturing. Equipment must be manufactured, assembled, and tested before delivery. Quality inspections must be conducted to ensure compliance with specifications. Installation and integration. 1. System installation. Installation of the ESD F&G equipment must be planned and executed to minimize disruption to existing operations. The installation process should follow the provided installation guides and configuration manuals. 2. System integration. Integration with existing systems must be seamless, with thorough testing to verify functionality. The vendor must coordinate closely with other system vendors to ensure smooth data exchange and compatibility. Testing and commissioning. 1. Factory acceptance testing, FAT. Comprehensive FAT must be conducted to validate the system's performance before delivery. FAT procedures should include functional testing, performance testing, and integration testing. 2. Site acceptance testing, SAT. S8 must be performed after installation to ensure the system functions correctly in the operational environment. S8 procedures should include point-to-point checks, system functionality tests, and validation against design specifications. 3. Commissioning assistance. Commissioning assistance must be provided to support the initial startup and address any issues that arise. The vendor must provide on-site support during the commissioning phase, including loop checking and troubleshooting. Training and support. 1. Training programs. Comprehensive training programs must be provided for operators, maintenance personnel, and engineers. Training should cover system operation, maintenance procedures, troubleshooting techniques, and best practices. 2. Ongoing support. Ongoings be available during the startup phase and for a specified period afterward to ensure smooth operation. Support agreements should be in place for timely provision of specialist services and replacement parts. Warranty and maintenance. 1. Warranty. The ESD F&G system must be covered by a warranty for a specified period, covering system components and performance. The warranty should include terms for repair or replacement of faulty components. 2. Maintenance plan. A maintenance plan must be established, including scheduled inspections, preventive maintenance, and access to spare parts. The plan should outline procedures for routine maintenance and emergency repairs. Compliance and quality assurance. 1. Industry standards. All project activities must comply with relevant industry standards, codes, and regulatory requirements. The ESD F&G system must meet the specified safety and performance standards. 2. Quality assurance. Quality assurance processes must be implemented to ensure all deliverables meet the specified requirements. Any conflicts or issues must be promptly addressed and resolved in consultation with the client. By following this project execution plan, the successful implementation of the ESD F&G system will be ensured, delivering a reliable and efficient safety solution that meets all specified requirements.